Hello everyone and welcome to another video where today I'm going to show you how I added aerials to GoslingUtils because it's been quite popular on the Discord recently and I thought, well, I got it to work kind of and maybe someone can improve on my ideas and maybe I can help some people with how I did it. So we're going to take a look into it. We're first going to look how I just did the general implementation of aerials and then how I added it to the find hits tool, which is down here, which was really easy. If you're just wondering about that, I just basically it's if the ball is above 600 units, then we just do this because jump shot takes care up to 300 units, aerial shot between 300 and 600, so otherwise we'd use that. And I have no clue how to use define slope because aerials has I created the is viable function from ROU, which is where my general aerial routine is based on. So I made a general routine class, which is what super is. So don't pay much attention to that. Well, you have your ball location, which is the point you're gonna hit the ball, or at least the location the ball will eventually be. The intercept time is the time the ball is gonna be there in like absolute game time, so not 5 seconds from now, but like at seconds 55.33 or something. That's because the find tools uses this to do the shot valid method. So I thought, well, I keep it consistent with all the other routines around. Target is the way you want to look when you hit the ball. So it's like your final orientation as well. But I use a vector. Yeah, I used which was once again would be the best shot vector also used in tools. So I first rewrote it one way, and then I wanted to implement it in tools and had to rearrange these variables. But so it might be a little bit messier down there, but that's alright. Self-to jumping is basically on ground. It's really great naming. It's from RU, but it makes sense. It's like, oh, if you're on ground, you wanna do your double jumping part. So self-to jumping makes kind of sense. So yeah, that's that. These are timers which I settled to -1, which is done in the flip as well. So I try to use a consistent state with that. And the counter is also from the flip, which we'll all see in a bit. So the first time you run it, also note that I use a drone, which is a car object. Because I use a hive mind, I can have 3 of my own cars. So I want to specify which car I want to run this mechanic on. So I give in the drone and then the agent. For most people, if you just use GoslingUtils, drone is just agent.me. So it's alright. So probably makes sense. So if the time is -1, so the first time you run it, you put elapse to 0, and then self.time to the agent.time, and then you can check the amount of time you've run with elapsed. And then I think T and elapsed are the same. I have to look a little bit into the code. It's not degraded. T is basically the time you have left, your time remaining, so your intercept time dot the current time. Yeah, this is from RU. You just add something to your location, so it's like math and shit. Just I don't know, it works. Yeah, you add to your velocity. Do something with gravity. I don't entirely know how it works. I think it just protects where you're gonna be. And then if you're jumping, so either you're on the ground, which means you're gonna start jumping, or you're currently jumping. I have this double jump method. Once again, the first time you run it, you set up your jump elapsed and your jump time, so well, how long have I been jumping, which is close to the flip, but you don't really have a bit royal, you just double jump. So tau is how long your jump is remaining, because that's also used to add to that if you have an X factor, XF variable from above, because if you jump, you get an extra velocity boost, so it takes into account of that to project where you're going to be in a bit. And this is the initial speed, because the first time you press jump, you get a bigger boost, but you only get it once. And otherwise, you just have your consistent jump acceleration and jump speed. I think this has all been modeled by Chip. Probably explained in his blogs if you really want to see how that works. Otherwise, this is just the jumping controller. If if we haven't jumped for 0.2 seconds, which is the maximum you can hold your first jump for, we jump. Otherwise, we'll just count 3 frames to put it to false. I don't know, it's just safe. It's like, if you skip a frame or two, it still works. And then you just have that counter working. So, if you're above the timer, you still have 3 frames. And otherwise, that actually always takes 3 frames. So if you skip frames, it actually takes longer, but that's alright. And otherwise, you have this timer here to do your second jump as well to get that extra boost, which I couldn't get to work in RU, but seeing that I implemented my own double jump function, it kind of works. Self-dot jumping, which is not controller jump. So this is your jump input. This is the thing that decides if we're still doing the double jump. That is just jump up smaller than or jump max duration. I think that's wrong. Now I think about it. Because otherwise it goes false if you go with this. Okay, that's interesting. I have to look into that. Why does it work then? Oh, well, this is also after the dead light. So you probably want to put this to 0.3 because as long as it's smaller than 0.3, we're doing this. That's interesting. I don't know why that works. Okay, well, always good to double check your code, apparently. Delta X is just the offset of the ball location that your X have. So, that's like the projected position you're going to be in, what your current velocity and like the added jump and whatever. And then, how far away are you going to feel from the ball. The direction is, well, what is the vector pointing to? If you don't have any target, we draw this. Oh, if the target is just my rendering, so I see where self-dot target looks to. I added it for debugging. I don't really need it anymore. If your delta x, so your offset from where you're projected to be versus the ball, is over 50 units, then we use the default PD controller, which is inside of GoslingUtils, which tells you the pitch, the yaw, and the roll to look to that location, which we do a local of. Otherwise, so if we're going on track towards the ball, if you have a target specified, we'll rotate to look at our target vector, which we need local as well. So you pass on your best shot vector is I think from the center, and otherwise you look at this. I don't know why this works. I think you just look at the ball with this. Yeah, makes sense. This is a little check. So yeah, this is what happens is these just override steer, controller, yaw, pitch by itself. But if you do your double jump, if you do your second jump, if you give a roll, pitch, or yaw input, you do like your feels side flip band or feels back flip band, what everyone always does in ranked, or at least I always do that in ranked. So you want to make sure that, especially just during this second jump, you don't give any inputs to make a weird dodge. And then this is for boosting purposes. So you take your angle between the direction. I think this should be angle 3D because it uses angle 2D, and I implemented my own 3D function. I think you want to have it 3D because you're also taking your Z factor. Right? Okay, cool. And then so the classic angle in GoslingUtils is angle 2D because it flattens the functions. If you want it in 3D, you just don't flatten them, and otherwise it's pretty much the same function. But once again, all the source code is also on my GitHub, and otherwise you can always ping me on the Discord. Yeah, that's already two mistakes I've also spotted in my code, so it's great to always recheck your code. So if that angle was small, so the direction is once again that delta x, so we're going into the right direction. If the factor is pretty big, you're gonna turn on boost. I don't know why throttle is off here. You probably want to add throttle because gives boost, but I don't know. Maybe it's the inline mechanic where boost also enables throttle. I don't know why that's it. I think I just copied that from RU. I think you could do without that, to be honest. Otherwise, you turn off boost and you just throttle a little bit. I have no clue why this is. I took this from RU. Probably could be optimized a little bit. And if you're just all out of the way, you don't boost or throttle because you don't want to boost in the wrong direction, I suppose. It's weirder that you cap your throttle, and yeah, boost is of course a Boolean value. I think you could throttle here. Wouldn't make too much of a difference. And then if your time is up or not shot valid, is not valid. Your shot is not valid anymore. We pop it, and then I just push the recovery because you're in the air, so you probably want to recover. I up the threshold because the current way I have it in tools is well, if the ball is over 600 units, we do the ball location with a little bit of an offset, which it's about personal preferences, because if you rotate your car while hitting the ball, it could be that you just hit it with the side of your car because you did rotate, but then you still put it in the wrong direction. Wait, I can probably show you in Rocket League if I start it up. What's fast up speed times? Cool. Okay, just pretend this is in the air. I'm not gonna set up a ball because it's gonna. So like, if you want to have an aerial that puts it to the right side, you can like come in, jump, and be like this, but then you still hit it forward. But if you do it offset, so your vector is pointing in this direction, right? So if you have your offset, you will try to hit it at this location. So you will put it more to the side. So you will hit it on the corner. Of course, it's not great if you try to do a 90-degree aerial, which is why an offset is not ideal at all cost. But I generally like to have it because I want to have it in case you want to do a little bit to the side. It works genuinely very well. But yeah, people are divided if you want to have that offset, as well as do you want to have that target vector at the end, because once again you might hit the ball with the side and not with the nose or the side of like front of your car, which generates the most power. So probably have to have something to see whether it's better to do this or just hit the ball full on. But you probably need some simulation for that, and then run a couple of different variations and see which one is the best. Currently, I don't have the simulations implemented yet. I just copied the is viable one, which is just a cheap way to say, well, this aerial is probably viable or probably isn't. And that's just generally what I use. So for that function, it's once again from RU. You just create your aerial object and just go is viable on it with, once again, I need to add in the drone I want to see if it's viable for, because I don't want the velocity of another drone, because then it definitely goes wrong. And time is just agent.time, but I don't want to pass on a long agent, so I was like, well, just give it on time. So T once again is T remaining. You do your XF, your VF. This is just once again projection where you're going to be, so you just do the same, but this time you see if that is actually valid. So you delta X once again. Somehow it's called F here. You do your angle 3D here, which I did correctly because once again I used angle 2D here, and it wasn't like, yeah, I can't do this. I don't know why, but it didn't work out. Or it gave like an angle of 0 and then this broke. I don't know. I had some errors here, but they're resolved now. So turn time is this function, which is stolen from someone's old code. I don't know who, but credit to them. Or this might be the oldest version of RU, which had like this cheap is viable. Currently, they have the reorientate simulation, which once again gives better results, but also takes up more computation time and is harder to implement. But yeah, implementing simulations is definitely a good thing. You take your time, and then I don't know. This is like some math as well to see. Well, do we have enough boost? Do we have enough time? No clue why this. Well, is our velocity estimate like a legitimate feasible speed? It works. It's not perfect. Probably far from perfect, but it's pretty decent. So that's generally how I implemented it all. I also had a way to test that because it's nice to test. So We'll enable the run test scenario, which once again I use from the RU example bots. You just have a couple of states. You have your reset state, in which you just do some random state setting where the ball gets put into the air, which is also like 90% of the code in here. You have your wait statement, because once again after state setting the ball prediction is a little bit off, and then you go for weird aerial. So waiting a couple of 10 seconds, a tenth of a second, but then a couple of them, 0.2, probably easy to say. Gives you that extra time, and otherwise you set up your aerial here. I have this push up method. Basically what it does, it's like, well, gonna clear it up. Basically this is my back corner, my right corner, the enemy goal. There's an attempt at passing, and then we're just like, well, can we hit an aerial shot, a jump shot, or a proper aerial towards one of these locations? Yes. If you can do a goal, shoot on goal, always shoot on goal. If we can pass, shoot, pass, and always just if we can at least clear it up field, do that. And then this was my check to see if it didn't take multiple frames, which it might if you run it in 120 FPS, but then it's like very few. Generally, it's somehow really optimized, so bought on by Goose, I suppose. Well, where are we? Oh, we were in run test. So yeah, so that just sets up your aerial. Currently, you probably for first testing, I just pushed the aerial directly if it was viable. It's in the example bot of RU. Basically, your pseudocode looks like you get your ball prediction. I'm not gonna type it all out. It's, you have your ball prediction, then you just loop over it for E in range, num slices. You take like the location if ball.c over like 600. You create your aerial object. Aerial is aerial ball, and then I divided by 60. If aerial dot is viable, push aerial. If something like this, it just generally just pushes the first possible aerial. If that works, it generally would work in your tools as well. But seeing I already have it working in push shot, I'm not gonna add it right now. And then you have your like 5 seconds to actually run it all, and then we just clear everything and start over. So I will run that real quick to demonstrate what that does, and then we'll just wrap it up. It's generally not about like line for line, because once again I haven't much of an idea how it all works. I generally know like the IDs behind it, and I've read Chip's blogs, which if you really want to get an in-depth view of how all the maths behind it work, definitely go check that out. But yeah, if you need help implementing anything, or just want to talk about it, I'm always on the Discord, and my source code will be linked in the description, which is my GitHub. And then I hope we get an of course I already had Rocket League running, so it doesn't like when you do that. So I have to restart Rocket League real quick. Let it run with the framework, and then we'll do a little bit of a setup to show you off. Or is it not gonna start up Rocket League right now? Oh, it does. Okay, cool. There it is. I didn't see it on my recorder yet. Okay, I see it now. Cool lag. We have a fancy map though. That's definitely great. Also got a fancy loadout. So you see the aerial in action. You see it going for the ball. Absolutely didn't put it on target there. It just didn't even rotate. It will do here. At the end it will rotate a little bit towards the goal. Depends on how much time it has to rotate as well. Of course, if you can simulate it, you can check if your rotation at the end is correct. But I'm just happy it hits the ball in the air and pretty solid. Puts it on target here. It's not the greatest aerials, but it works. And if you have improvements, I'm also happy to hear them, because I could really use them. But yeah, this is how I implemented aerials to the Gosling Utilities method. And I hope you learned something. took something away from it and can add it to your own bot, and then we're happy to see it in a in a show match or something. So if you have working arrows and you want to show them off, also let me know, and you can play them on stream. So yeah. Anyway, thanks everyone for watching, and see you next time. Can we still get one more goal to end the video with, or is that too much to ask? We sometimes also get a lucky double tap because the way it recovers with its buff, but I don't think we're gonna get a goal. Too much pressure. Oh, the double touch? Nah, the double touch block. Well, anyway, thanks everyone for watching. See you next time. Bye.